So for those that I haven't met yet, I'm Brenton Wine from Autodesk. I'm the Manager of Education Programs for Australia, New Zealand, Japan, Korea. We're really fortunate today to have another Autodesk education person present in Professor Glenn Katz. Now, Glenn is also a professor at Stanford University in architecture. So he's a very busy person with that role and also the role at Autodesk. And he's based in our San Francisco office. So if you ever do travel to the US and get to San Francisco, look up Glenn or the Autodesk education team there and do a tour of the gallery where a lot of our innovations, our designs, creations that have been made are on display there. And it's a really good tour to have a look at. So I'll pass it over to Glenn. It's 5:30 time in San Francisco, so still working hours there.
No worries.
And I hope you enjoy Glenn's presentation. Thank you.
Thank you very much, Brenton and Bernard and everyone for having me. I'm looking forward to this because really the whole notion of 3D printing and things we can do in 3D printing, especially in architecture, is really, it's really one of my favorite topics. I come at it from the AEC side. I teach basic building information modeling in an architecture program at Stanford. And just the impact that 3D printing is starting to have on that space is huge. So I wanted to go ahead and share some just sort of cool examples of things I'm seeing and hopefully add a little bit to the discussion, because I think when we start thinking about architectural printing or 3D printing from an architectural perspective, it really just takes us to a whole different scale and way of thinking about things. So basically what we're going to do is show you really hopefully a lot of different examples of how 3D printing is being used within that space. That'll just kind of get you thinking more broadly about really how this technology could ultimately be transforming the entire industry. So in terms of getting going, let me start with this whole notion of really just architecture and form and how the two things work together. In the architecture space, there's always this notion about form and function and how these different things need to work together. And people have a lot of different attitudes about really which side will be driving the equation. But generally, we think about needs, user needs, really driving the design work we're doing, helping us dictate the form and to deliver a certain type of functionality. And that's actually one half of the equation. We used to think it was strictly related to that. What we've sort of found more recently, though, is the whole notion of delighting people with their design is very important too. And if you look at a lot of the really cool user-centered design going on, the things that people really talk about as being seminal design advancements, they had this function of delighting people too. It wasn't just that it was sort of needing some functional requirements. So in thinking about 3D printing and how it applies to architecture, I like to actually start historically a little bit. So I wanted to think about it a little bit historically and kind of draw on some precedents. This is an example from like just Gothic architecture. And you can see back in the Gothic times, we produced incredibly ornate designs. And this was largely due to the fact that we had a lot of people who could do this type of work by hand. And they were committed to going ahead and creating these sorts of designs. We created designs that were they were more than just functional. They were actually quite artistic. Now, this next example is actually Gaudi's work. I love Gaudi's work, and if you ever go to Barcelona, you have to go see the Sagrada Familia. One of the great examples of kind of taking interesting geometric forms and illustrating them about architecture. It's a fantastic building that's taken 100 years to complete, and it's still in production right now. So sometimes production really prevents us from creating really fantastic architecture. What happened along the way was somewhere around the time of the machine age, we started getting very sterile in architecture, and it was all about functionality, efficiency. And what happened as part of that whole international movement was a lot of the personalization, a lot of the delight got stripped out of architecture. And it was largely driven by the need for producing things when we started thinking about things being assembled objects, having things that were rectilinear forms, things that could be produced easily. That became the driving consideration, and we really lost an awful lot of the personality from architecture, as well as the ability to delight people. People look at this image, and this was Corbusier's image of really what the new city could be like, and a lot of people look at that and say, yuck, just very sterile, wouldn't be a nice place to live. So we want to think about the notion of really what would happen if our design options weren't limited by our production techniques. And really, what if the whole notion of adding complexity, adding freedom to the form was actually free, if we didn't really have to kind of think about that as a design constraint? So I'm going to show you a number of different examples that really sort of explore that. So starting at the smallest scale, there's this whole notion of, I love this little guy, it's called the 3D Doodler. It's a 3D printing pen, and it starts with that idea that the simplest thing to do is actually take a pen in hand and just start creating design. But what if we could actually do that in 3D? So let me kind of show you a little bit of a video snippet. So what's happening is there's a small pen that's extruding plastic through the head, but what people are able to do is just doodle in 3D, and the plastic is curing immediately. It's allowing people to create 3D form just by drawing. Here you're actually seeing someone just sketching over a model of the Eiffel Tower and then assembling that. So I like to show that, really not in terms of the ultimate of where this is going, but just to sort of illustrate just how simple it can be. Just the idea of moving sketching to 3D is really kind of a start, and there's a freedom to that. There's something I can do with that pen that would be very hard for me to do with some of the computer drafting and modeling software. Okay. If I keep on going with the notion of 3D prototyping and just starting to explore form, I could look at, there's some really interesting work being done by Ron Rael and Virginia Sanfratello at UC Berkeley, and they look at just prototyping objects, organic forms, and how we can create simple cubes. Here the organic form is doing something like a big fruit bowl. But moving to higher and higher scales, this is the example of a bench that's kind of extruded out of a very panelized system, call it the slug bench. Moving to bigger and bigger scales, this is more like an igloo made of salt, of all things. If you could think about 3D printing salt, we always talk about plastics, but being able to mix salt in a binding agent, we can create things like this. And it's even moving ahead to thinking about creating complete forms like sheds and houses. Okay. Here's another project that's really all about a big 3D printed installation. This is something called Echoviron. The idea is to build some sort of structure in the California redwoods. This actually was built. I'm just going to give you a sense of how they did this. It's really kind of interesting, but it's again thinking about 3D printing at a higher scale. And let me just start the video and kind of give you a sense of what they did. What they're doing is they computer modeled the entire structure and had a series of very highly individualized blocks. And here they are 3D printing the blocks. So they're creating a bunch of plastic blocks that would actually be assembled by students out in the field. Now this took a long time. You know, the whole structure being 10 by 10 by 8. This took just hours and hours of printers working full time to go ahead and create something like this. Let me just zoom ahead a little bit to kind of show you what the finished product looks like though. The students then took those blocks out to the field and started assembling them. So that'll give you a sense of Echoviron. This is still more at the scale of what I'll call installation. It's really not producing architecture. It's just producing small-scale architecture, but it's not really creating kind of full-scale yet. And we're just going to keep on moving up that continuum. The next example I wanted to show you is something called Digital Grotesque, and it's really kind of an interesting one. This was created using a voxeljet printer, and it's actually the largest installation that's been created to date. This is created, again, as a series of blocks. Let me just show you. It's very Gothic in its nature, and it's really, really quite interesting. So you see the scale of the person standing in front of it. They've created, it's really almost like a grotto. Okay, but let's see if we can kind of show you what this one looks like. And I'll start this fairly early. Actually, for all these things, we can send you all the links and the URLs to the videos and stuff like that. There's really some incredible stuff out there to take a look at. Here they're using the same sort of printing technology. We're moving a print head in an XY space and then moving up layer at a time. But here they're using a different sort of material. They're actually using, it's a bonding agent with a sand-like material. And what you're seeing they're doing there is actually wiping away, that's the support material. That's actually part of the process to support this structure as they build it. Then they kind of blow it all out with some air guns. You know, this allows them to create sort of incredible architecture down to 1/10 of a meter. really getting very much back towards the Gaudi-esque or the notion of the Gothic architecture. Now they're spray painting it all white, just because I think they're trying to clean up the form. Let's take a look at what it looks like as an actual room. So this is the grotto. You can see the assembly of the blocks all together. But it's creating just sort of a very interesting form. 16 square meters. You sort of see the idea of coming into the grotto. But we're starting to have these full-scale installations, which are really quite interesting and quite well, evocative. There's a real emotional experience you get going into a space like that. Okay. At a high level, if we really get to the building level, I want to share just a couple of projects with you. This is something, the Broad Museum being built in Los Angeles. It's kind of designed to be 3D printed. That whole skin is 3D printed. And that skin is really one of the unique features. It's the veil around the vault, since it's an exhibition space around an archive. You know, that skin is not only sort of an exterior feature, it actually plays into the interior architecture too. And what I want to start thinking about is these interesting organic forms can have a huge impact on really how people are experiencing the architecture. So you sort of see, being able to see the skin through the translucent glass walls, experiencing inside, even how that plays into the gallery roofs. Oops, let me go back over there. The way they're doing this is kind of an interesting one. They're not actually 3D printing the material, the skin. That'll actually be cast. But what they're doing is printing the negatives. So they're printing the forms that will then be used to cast that skin on the outside. So we can either do the positive side or the negative side. In this case, we wanted a nice durable material. So we're using the computer technology to model that form very uniquely. All those panels are unique, and then using that to cast those individual elements. Okay, this is another interesting example I like, again, at a much bigger scale. Some students are, this is the architecture firm. I'm trying to think, where is it? Is it in Denmark? I think it's in Denmark. They're somewhere in Northern Europe. They're going through and talking about producing an entire house that's very much like a big Mobius strip. Kind of zoom up there a little bit. But they're talking about actually using a D-shaped printer, which will produce sections up to 6 by 9 meters at a time. Okay, again, not using plastic, using a mixture of sand and a binding agent, but being able to create full-scale architecture that we can live in, just being 3D printed. So let me show you one final example here, kind of at that very large scale. This is some work by Baruch Koshnevas at the University of Southern California. He's working on the notion of actually being able to 3D print entire homes. So you can see the rig there that would move in the XY direction and actually deposit material, in this case a concrete-like material. But it makes us think about just creating a house very differently. If instead of actually casting the walls and running the pipes through them, if you could actually print the walls and print things like piping and electrical conduits just in place, it just really changes the way we start thinking about architecture. So let me open this one up, see if I can get to a good spot in this one. So this is the actual house being prototyped. You see we're moving the nozzle. In this case, it's secreting that concrete mix. There's a picture of the rig itself that can be used. Okay, so let's go ahead and move on from that. So the idea is really we wanted to look at a whole series of projects at different scales, starting with those very small things we could produce to a pen, all the way up to doing full-scale printing. Yeah, and this is really the range of things I want you to start thinking about in terms of how their 3D printing is being used. It's not just little things that pop off of a MakerBot or actually come out of an object printer. It can be actually full-scale things we're starting to look at now too. Now, in terms of getting things ready for 3D printing, I want to just point out a couple really cool technologies you should know about just to help people get started. One that I really love is one called 123D Catch. It lets you create 3D models from photos that you can print. So here's some examples of, I was recently traveling in Europe, and I found at the Achillean Palace on the island of Corfu a statue of Achilles that I really like. So I made a 3D model by capturing him with photographs. Okay, and you can see that's the 3D model that came from the series of photographs, just using consumer technology, stuff that you can do either with a digital camera, or I did it actually with an iPhone that was made up out of a series of like 40 photographs to go through and produce this. So people can get started doing 3D printing very easily. And in this case, I was just capturing architectural artifacts. And it was a lot easier to do that with photographs as opposed to trying to model that from scratch. Another kind of technology that's very, very useful for creating these 3D models is if you're using a building modeling tool like Revit, which I use day in and day out, anything can actually be selected within Revit and then exported through something called the STL exporter. So creating that common file format that we use for so much of the 3D printing. And in this case, I had a kind of custom railway pattern that I designed. I wanted to think about 3D printing that. I could either do that as a prototype first, just to understand it as a 3D form, or I could actually take that to full-scale production. But again, the STL files exported, I can print that out on my MakerBot or print it out on a much bigger printer just really quickly. So the distance between having designs in my mind and actually being able to realize them at full scale, or at least in 3D form, is really getting very, very small. So a couple of different communities I want to point out to you that are just really great if you're interested in architectural printing. There's Shapeways, which just is a great place all about 3D printing and how it's being used. There's also a really good site called Thingiverse. And if you like architectural models, there's something called the Arctober collection. It's a whole series of architectural models they put together in a bunch of Arctober. If you want to point people to that collection, there's a bunch of 3D models you can download and print. Oh, great models of architectural objects. The Barcelona Pavilion. What is it? Notre Dame. Any of the great buildings that we always think about, you can get 3D models and just get started printing them today. Finally, just to wrap up, I wanted you to leave you with the notion of really what some of the advantages of 3D printing are in architecture. And the big one that we start out with is just this whole notion of we're actually able to get complexity back in our design without adding cost to it. So we're really liberated from the manufacturing constraints, and that allows us to explore and create these new forms that we haven't been able to when we were stuck having to assemble things. This design freedom is giving us aesthetic and functional advantages because we can create these organic forms. And organic forms, it's turning out, are actually not only pretty and interesting and delightful to people, but they actually allow us to get higher strength objects that have better material efficiencies, because when we mimic a lot of things in nature, when we use that sort of learning from nature and adapting it, we actually get very, very efficient forms that are very, very strong. And finally, out of the 3D printing, we're really actually starting to get some production advantages. So when we start talking about printing entire houses, the idea that we could actually produce houses for the masses at a lower cost because we don't have the labor costs, the materials are much simpler to produce them, as well as be able to achieve greater speed, we're getting lots of advantages that are ultimately really going to drive the use of 3D production at this larger scale, and hopefully really improve the world by being able to kind of bring building technology to people who might not be able to afford it today. So that same sort of technology we think about using in parts of the world where construction's hard, or even using it on the moon or on Mars, or in environments where we can't actually send people to assemble things. So a lot of advantages, and I think you're just going to see incredible growth in this space over the next 3 or 4 years. So definitely keep your eyes on it. So that's where I wanted to kind of leave you today in terms of just introducing the topic. But let me go and just kind of open it up to questions now, because I think that really the whole idea of what we're doing with it and how it can be used, it really gets to be sort of very, very interesting. So how about from your side? Let me see if I can kind of bring up the image again. Well, I'm trying to bring up the image again, but maybe I can't so much. But go ahead and let me just turn it over to you guys and start to see what sort of questions you have.
Okay. So thank you, Glenn. Any questions that anyone would like to ask? I think you want to stump them, Glenn.
Oh no! Well, let me ask you something else. As we think about these sorts of technologies and using these sorts of technologies, is this something you're seeing in Australia today? Are people talking about this in this sort of form? Or, so often when I talk about 3D printing, people are thinking about little, objects made of plastic that are really just a few feet big. Like, is anyone talking about printing at this scale? Or like, what's the uptake in terms of thinking about this in an architectural sense in Australia?
Would anyone like to? Yeah.
Well, yeah, I think it's only just really getting started, really small scale, like you were saying. I think it's going to be a while before people sort of start to embrace really bringing it beyond small prototype models and start thinking about, designing components or even sharing components like online, even like we talk about Thingiverse and those sort of things like that.
Fantastic. I think it often starts that way. It starts with seeding things, and after that, designers start thinking about using it as a capability. Really, some very interesting designers are starting to think. I see things. I think you'll start seeing different facade components in some of the most interesting buildings being built. Just panelized systems on the facades that'll really get people kind of engaged with the whole notion of how unique 3D printing can be. But it'll really start growing pretty rapidly as some of these buildings get built, and they're on the world stage. They're gonna start being emulated by architects everywhere.
A question down the front here.
I was just wondering whether you can have a 3D model produced from 2D architectural plans.
That's a very good question. A lot of people like to start with that. So it's a very common request. Usually what we do is you can start with 2D architectural plans, and there are some people who are working on completely automated systems. So you'll actually see some software that says it can do a good job of that. I say it does a pretty good job of that, but I think there's always some fixing things up afterwards. You can take a 2D drawing, and use it to just really figure out where the walls will be. The harder part is really trying to figure out the heights and understand just the vertical relationships that come off of those. But there are definitely people working on that problem right now in universities, trying to say, can we, in the same way we can do it with photographs, can we take a series of 2D views and interpret the meaning and put it back together? So I'd say there's not great commercial solutions for that today, but, again, ask me 3 years from now, and I'll probably have a much better answer for you on that one.
Any other questions at all for Glenn?
Actually, I have another question, like in terms of 3D printing and even what you're seeing here as part of the showcase. A lot of these architectural projects are talking about, printing in, sand and making artificial sandstone, or just, any number of materials that could be bound together. As we're talking about 3D printing, there at the showcase, are we thinking mostly about plastics and, different sorts of resins? Is anyone talking about, we can now print, with metals, we can print with ceramics. There's even people talking about using 3D printing to do things like print human stem cells to create new organs. So it's amazing what you can think about in terms of the ability to just lay down materials in a program pattern. But like, what sorts of things are people talking about at the showcase there?
Yeah, we've actually got a question over the right-hand side. You might not be able to see the chat.
Oh, please.
Sorry, Glenn, I don't think
Jump in.
I don't think, but I'll ask. When you spoke about that interested me. I mean, when you talk about big material projects in size for 3D printing, do you know anyone that's giving thought to kind of the manufacturing implications in terms of material economies? I mean, right now we use wood to build a lot of houses. Has anyone kind of given any thought to how that's going to change, our material needs moving forward? I mean, there's still going to be material needed. What are those going to be? Where is it going to come from? And then all the, leave it at that.
Oh, very, very good question, because it really does change the whole notion of materiality very much, because, we won't really use wood. Wood so much got used because it was sort of a very easily formable system. It was easy to cut and alter as we needed. the ability to actually use local materials, really from a sustainability standpoint, is pretty fantastic. So in a lot of the projects now, we're thinking about trying to use local materials, whether it's sand or something that's native in the environment, and bond that together. So when we talk about like this USC work, I think has pushed that probably the furthest in terms, there they were building a house out of a concrete-like material. But he's actually done some interesting proposals thinking about how we could use that same sort of system with a rig, actually using like lunar soil, so using the moon dust and bond that together, because we don't want to be, a big part of like making this more efficient is not transporting materials to the environments, but actually using the native materials. And can we use the form itself, to actually go through and be able to kind of create very efficient shapes, that'll hold together using those materials. So some of his work, a lot of it, like he's actually from, I believe, the Middle East. So he's looking at projects where, the forms there are made out of like, different sorts of ceramics and stacked blocks. So creating domes that actually can be formed out of thin shell materials made of the desert sands. So it definitely will have a very big impact on the types of materials we're using, and especially at this large scale, we want to think about sustainable materials. With so many of the little objects that are made out of plastics and resins, they don't really have a great sustainability story yet. They will over time, but a lot of them aren't so biodegradable. But even, that Echoviron one, the one that was out in the redwood forest, that was made out of a biodegradable plastic. That was part of their mission. So to actually have something that's more organic and will degrade nicely as opposed to creating a lot of waste. So it's definitely going to change materiality.
Okay, thank you, Glenn. We're pretty much out of time. So on behalf of everyone here, thank you for your time this evening over in California. And
my pleasure. My pleasure. Thank you so much for having me. It was fantastic. So thank you. Enjoy the rest of your showcase.